This is chapter 4, problem number 25. And it says that a dart is thrown horizontally with an initial speed of 10 meters per second towards point P, the bullseye on a dartboard. It hits at point Q on the rim, vertically below P, 0.19 seconds later. What's the distance PQ? How far away from the dartboard is the dart released? So one of the hard things, in my opinion, about these sorts of problems is that you don't have a picture, and without a picture, it's hard to visualize what's happening. So my first step when doing problems like this is to draw a picture. And so if it's thrown horizontally, then I'm going to write V initial in the x direction, because it's horizontally, equals 10 meters per second. And then if it's thrown toward point P, then that means that horizontally over here, we have point P, because that's the bullseye of our dartboard. However, we know that gravity exists, so it's not going to go directly at point P, but instead it hits at point Q on the rim, vertically below P. So we're like, okay, here is point Q. And so the actual path that it's going to travel is going to be something like that until it gets there. So we want to know this distance right there. I'll call it my y distance because that's our vertical distance. And then we also want to know how far away from the dartboard is the dart released. So that is this distance right here. So I'll call this x naught, and I'll call that x final. So we want to know the y distance, we want to know the x distance. Fortunately for us, we know the time that it takes. So the time equals 0.19 seconds. And as we remember from learning about this, we know that time is the one thing that we can use in both the x direction and in the y direction. So I'm going to work with the x direction first. And so what I'm going to do is I'm going to write out all of the things that I know in the x direction. I know that v initial in the x direction equals 10 meters per second. I know that x initial, we're going to call that 0. We want to find this x right here. And we know the acceleration in the x direction because since we're in a gravitational field in the x direction, there is no acceleration, so that'll be 0. So with all of this x information, we can hopefully find this out. And of course, we know the time. So I'm going to use this kinematic equation right here. I'll just plug in everything that I know. So x, which is what we're looking for, this little dude right here, equals 0 plus v naught, that's 10, times our time, 0.19, plus 1/2 times 0 is our acceleration, times our time, which doesn't matter too much because it's multiplied by 0 in that location. So our horizontal distance is going to be 1.9 meters. And that is great news because that is the answer to part B. So now let's go back and figure out the answer to part A, which is in the y direction. So when we're dealing with kinematics, it is fine to use any of these kinematic equations as long as our acceleration is constant. So here that's fine because it was 0. In the y direction, it's constant because our acceleration is gravity. And as long as we're using this, if everything is in the y direction, then that will work out for us. Just like right here, we did everything in the x direction. So now over here, I'm going to write down what we know in the y direction. So initial velocity in the y direction equals 0 because it's completely horizontal to begin with. I'm going to call this location y naught, and here will be my final y. And so we'll solve like that. So y naught equals 0. Y is what we were solving for. A in the y direction is negative 9.8 meters per second squared because that is gravity. And now we will solve for our distance. Oh, I'm sorry. This is what we're looking for. So we don't know that. And so let's try to solve for this. So instead of saying x equals x naught plus v naught t plus 1/2 at squared, we will have y equals y naught plus v naught y t plus 1/2 a y t squared. So y equals 0, 0 times our time, plus 1/2 negative 9.8, 0.19 squared. And so if you work this out on your calculator, you will find out that your distance in the y is negative 0.17689. And so the distance below, which is what it's asking for, is 0.18 meters below. And how far away from the dartboard is it released? That's 1.9 meters. And we are done.